Hello and welcome back to another episode of Cypher. We are on to room 6, digital cryptography. Well, let's just read, I guess. Modern day cryptography continues to use steganography, transposition, and substitution techniques combined with the speed of the mechanized era and with greater key lengths to create vastly complex ciphers. One important difference is that digital ciphers work on the binary representations of letters instead of working directly with the letters themselves. For example, using ASCII encoding A is represented by the sequence 01000001. Digital steganography allows the binary representation of a message to be hidden in any type of digital file. Often it has no noticeable artifacts for the user and can be extremely well hidden. However, forensic scrutiny of the file will still reveal the message. Digital transposition is particularly effective as the plaintext letter is now fractionalized into many digits which can be separated. Shuffling the positions of these numbers now also has the effect of changing the letter itself. True. Digital substitution can be performed by combining a plaintext letters binary sequence and a keytext letters binary sequence using an XOR, exclusive OR, logic gate. This process is symmetrical, so combining a ciphertext with its key will return it back into plain text. Modern ciphers split the plain text up into blocks, which are enciphered using a series of substitution and transposition steps. Encipherment is repeated in many rounds and uses keys of at least 128 bits to create ciphertexts which are resistant to all known forms of attack. Now we're solving one of those. Probably not. Alright, so the capital letters 65, 66 and on, and then the lowercase letters 97, 98, 99 and on. And then in binary, we know how binary works by now. Or I do, at least. I've known for a while. We've used it before. Did I actually explain it? I don't remember. But this is relatively self-explanatory if you really look at it. Like, it's just adding up the values. Like in the top row there, only the one column is like 1, so we only have the 1 to add up, and then the next row we have 2 and 1 being 1, so 2 and 1 is 3, and then the next column we have 8, 2 and 1 makes 11, and in this column down here we have 16, 8 and 2, which does in fact make 26. And an XOR gate only returns 1 if one of the two things we compare is 1 and the other one is 0. Whereas a normal OR gate would return 0, 1, 1, 1 here. An exclusive OR gate does not return 1 if both the plaintext and the key are 1. In this case, it returns 0. I don't know. That's that, I guess. Alright. Let's start. 0, 1, 1. Why do I do spacing here? I shouldn't do spacing, it's annoying. So are these, they're probably, I don't know. We'll be fine. Alright, so we have 8 bits, goes up to 128. So the first one, we have 64 plus 42 is 96, plus 4 is 100, I believe. Yeah, it seems right. Then we have 97, yes, 64, 32 plus 1. Then we have 64, 32 plus 16 is what? What did we say? 96, 106, 112, and then we also have, what, 4 more? 416? Doesn't make no sense anymore. Whatever, 116, we don't need to write them down. We can do them like this. And then we have 97 again. Presumably that is true. And if we say that this is this, then we have a D as our starting letter, because 100 would be D in this case. Then the 97 is an A. D. A. And 116 is probably a T, I'm guessing. Because the last one is an A again. Is that true? I don't want to look it up, but we probably need it anyway. It is true. Data. Or data. Moving on. So. I mean, I don't know. It's probably not just gonna be the same thing again. So we have hello there. Is hello like a key? But how would you use hello as a key? Because if you use an XOR gate, then hello is just like a whole bunch of stuff. So I don't know. Wait, oh yeah, there's one for each. Probably, yeah, we take the letters of hello, make them all into binary, and then use XOR on those 5 sequences, those 5 binary numbers, right? I need the ASCII alphabet somewhere. Because like this is just, it's too much work. Also, I'm not sure if you should use, it's caps, so we should probably use this one. Or not this one, but like we should start with the, in the 60s, not in the 60s, the 70s, I guess. I just want, why not print the whole alphabet here? Now I have to do it myself. Oh man. Let's just go over here, I guess, and write it all down or something. How many letters can I fit here in one like line, one row? I'm not sure. I have enough space. U, V. We could do. We could do a notepad for this, but I don't know if it's worth it. Alright, so where do we start? 65 and 97. So 65, 97, and then we just go. Kind of annoying, honestly. This is one where like using like an Excel sheet or a Google sheet or whatever, like a sheet thing, would be very useful because you could just autofill all of this. Which would be much faster than doing it manually, for sure. Or we could just look it up somewhere. We could just find an ASCII code thing online, I'm sure, and copy it out. That would also be better than this, but I already started this now, so I don't know. Stuck with this, I guess. I'm almost done. Well, not really. I'm getting there though. Yeah, that seems right. Okay. All right. So hello in caps gives us 72. And then 69, 76. Twice, obviously, for the 2 L's, and then the O is 79. Yes, seems right. I keep hitting the, well, it happened the first time today, but in this series, I keep hitting the caber, the microphone caber with my pencil. It's in the way. I need more desk space here. really the big problem is the gas of water is in the way a little bit, but the mixer is just huge, and I can't really move that. Anyway. So 72 in binary is 0, 1, 0, 0, 1, 0, 0, 0. Because 64 plus 8. And then our first input here, I'm hoping this is right because otherwise it's a huge waste of time. It's 0, 0, 1, 1, and 4 ones. And now we do XOR, which returns 0, 1, 1, 1, 0, 1, 1, 1. Really? That's kind of high, isn't it? So that's 64, 96, 100 and... what is it, 12? Yeah, 112, 16, 118, 119. Which would be a lowercase w, I think, if I wrote it down correctly. Who knows? And then we have an E. Wait, is it the key? It doesn't matter, right? It doesn't matter. Which order? Yeah, yeah, of course it doesn't matter. 69 is E. We need 0, 1, 0, 0, 0, 1, 0, 1, right? 64 plus 4, 68 plus 1 is 69. And our second input here is 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, which gives us 0, 1, 1, 0, 1, 1, 1, 1, which turns out to be 64, 96, 104, 108, 110, 111, which happens to be an O. Sure. Running out of space, which is bad because this is the page that has everything on it. This is not good. I wasted a lot of space. I've been very liberal with like line breaks essentially, which is just not a good idea. So 76 in binary. Where do we go with this? Up here, I guess. Is 0, 1, 0, 1. No. What did I say? No. What am I looking for? 76. There we go. I found it again. So 64 plus 8, 72. Plus 4 is 76. Is that right? Yeah. I need this one twice actually, but let's just do 1 for now. And then the third input is 0, 0, 1, 1. 1, 1, 1, 0. And then that gives us 0, 1, 1, 1, 0, 0, 1, 0, which is 64, 96, 112, 114, I believe, which is an R. And we have the same thing again. 0, 1, 0, 0, 1, 1, 0, 0, and our next one down the line here is 0, 0, 1, 0, and a whole bunch of zeros, which gives us 0, 1, 1, 0, 1, 1, 0, 0, which gives us 96, 108, I believe. Which is an L, and then hello world is what this is, but let's do the last one just because the O is 79, 79 in binary is 0, What is a 0, 1? What am I looking for? 79. What am I doing? 72, 76, 8, 9. Alright, and the last one is 0, 0, 1, 0, 1, 0, 1, 1, which gives us 0, 1, 1, 0, 0, 1, 0, 0, which happens to be 6496 plus 4 is 100, which is a D, and that is correct. And that means that our encoded stuff is world, and the whole thing now says hello world, which, you know, that's like the first. It really shouldn't be anymore, I guess, but it used to be like your programming first steps, right? Just this. Anyway, moving on to the third one, and this is a new page for sure now, even though I hate because the alphabet, you know, we'll have to go back and forth. So this, you know, is less obvious. 2131 2572 is maybe our key, and the rest is the encoded stuff, I'm guessing. Because if it's not encoded, what would that be? I mean, it has to be encoded. That's the whole point of this game. We what, 98? But how do we turn 2131 2572 into something binary? Odd or even, maybe? 0111 0110. I'm just guessing that the 2 would have to be the 0 if that were right, because then otherwise all the leading zeros would turn into 1s, and then all our numbers would be too high, because we would start with 128 for all the values, and that's like outside of the scope of the ASCII alphabet. Do I have a better guess than this? I don't think I do. But that would be the same key for all the different... Or we look up the, like, there's also binary values for the numbers, I'm sure. We could look those up, and then, you know, that would actually make more sense. Or would it? No, but we have 8 numbers, and we only have 7 sets of binary here. I don't know which it is. I don't know which it is. I really don't. Yeah, I'm not sure what to do here. Because it will give us too, like, the numbers would be too low here, I think. If we do 0111, 0110 as the key, then what we would get would be 0001, 010, no, yeah, 0100, which is only what? I lost track. 16 plus 4 is only 20. That's too low. But that's definitely not it. Let's do some quick Googling, I guess. ASCII alphabet? ASCII table, that's what I want, yes. Maybe. Binary. Yeah, okay. And then number 2 in that would be 0011. I sound like I'm far away, I'm just looking at my left screen. 0011 001 0001. And that would give us what? 01010011, which at least is valid. 64 70 what is it? 83? I don't know. Maybe it would be an S, I guess. I don't know if that's right though. It doesn't seem quite right. Let's see, 0111 0101 is our second one here. And we will use a 1, I guess. I don't know, it doesn't seem right though. Because it doesn't line up right. Gives us 0 1 0 0 0 1 0 1. That's relatively low too. I don't know. That's an E, I think. Because it was 64, 68, 69. Yeah. SE. I mean, it's plausible that that is right, but it also is very plausible that it's just not. We can't really tell until we go all the way through. And that is sort of a concern for sure. Could we do anything else with this? I don't really know what we could do with this 2131 2572. It's just, you know, it just seems wrong based on the fact that there are 8 digits up top and then we have 7 things to decode. Which just doesn't seem like it would be that way, right? That's the only concern I have. Otherwise, I would just go and keep going with this for now to see if we get a solution or not. Yeah, I don't know. Do we want to do another letter? See if we make the start of a word here? It doesn't seem right though. What would 3 be? 0011 0011, and our third input is 0111 1001. That would give us, I don't know, 0100. And then 1011. What is it? 1011. don't know. So the highest digit up top is 7. And we have 7 codes. Maybe it's an order. No, it's not an order. 2, 1, 3, 1. There's already like 2 1s. Maybe we don't use all of them. Maybe the letters repeat. And it's not even encoded. What kind of letters are these actually? So 0, 1, 1, 0. 0, 0, 1, 0. What is that? Where am I? 0, 1, 1, 0. And then it's a lowercase b. I guess, sure. And then what's the next one? 0, 1, 1, 1. 0, 1, 0, 1 is a U. And the next one, what is that? A Y. Buy. Sure. What do we buy? That doesn't seem right. 0, 1, 1, 0. And then 2 zeros, 1, 1. There's a C. I don't know. But we're not using the, like, I don't know. How long is this episode? It's not long enough to end it, right? No, not really. Let's look at this one. Maybe I have a better idea for this one. Image. I don't really know what to do with that though. And so what's with the commas here too? Are we just separate us for maybe? But you don't really have a key here unless IMG somehow is the key. And it could be, but how? And then we have 1, 2, 3, 4 per row and 4 rows, so 16 total letters, I guess. So like using IMG and doing it like in the, like with the Visioneer stuff, it doesn't really make sense because it doesn't, like 3 doesn't go in 16. But I mean, it could just be use the I at the end and, you know, that's that, and you stop. I don't know. I don't know. I mean, that first number is 254, right? Because it's 1110, which is almost like the max value of, you know, like 8 bits, which would be just one lower than, you know, another bit. And we definitely can't do anything with that, so we need to have a key for this too. And then it's like 3 times the same thing there on the left hand side in that column, 1, 2, 3, and then the last one is just zeros. Okay, this does not make more sense, it makes less sense than the other one. What about this one? Nah, let's not even look at this one. Let's go back. What do we do with 2131 2572? I don't really know. What did we learn? If we have a key, we use the XOR gate. We don't have a key. Alright, I don't think we do. Maybe we should just try using those as key again for one more and see what the next letter is. Sure, let's do that. So 3 is Or did I do that one already? No, I did S and E, right? So 3 is 0, 0, 1, 1. 0, 0, 1, 1. That's easy to remember. And then the third row here is 0, 1, 1, 1. 1, 0, 0, 1, which leaves us with 0, 1, 0, 0, 1, 0, 1, 0. Which happens to be what? I do not know. It's 10, 10 at the end. A Che. No. SE Che is definitely not right. I'm looking up everything in that table now, in case you're wondering. It's called ASCII code character to binary, and it just has all the numbers and the letters in lowercase and uppercase, and then the binary code next to it, or next to them. And that is good, but it is also not useful here because this is clearly not what we're supposed to be doing. So what are we supposed to be doing with 2131 2572? The second one, the first one, the third one, the first one doesn't make sense. Because what do we do with that? Like, just decode like this, the second letter is a U. And the first is a B, so it would be UB, Y, B. UBIB, or something. That doesn't seem, you know. That is not right. Alright, but what else could we... Wait, did we learn anything else about this? Usually it makes it more difficult, so what else do we have? Yeah, it allows a binary representation of a message to be hidden in any type of digital file. Often its noticeable artifacts for use and can be extremely well hidden. Digital transposition is particularly effective, fractionalized into many digits which can be separated, shuffling the positions of these numbers. What if they're shuffled? What if they're shuffled? But how are they shuffled? I don't know. Yeah, I don't know. Yeah, I'm not sure what to do. How shuffle? How do we shuffle? Well, if we shuffle, then the key up top is how we shuffle. Well, if we move them, it doesn't change anything for the first three because they're sorted all the way through the columns. So that's just the same, 0, 1, 1. And then if we switch this one down 1, what do we get? We get 0, 0, 1, 1, 0, 1, 0. And the next one down 2 becomes 0, 1. Right? Yeah. 0, 0, 1, 0, 0. It's down 5 becomes what? 1, 2, 3, 4, 5. So we start right here. 0, 0, 1, 1. Is that right? I don't know. And then 0, 0, 1. 1, 2, 3, 4, 5. That seems right. And this one's shuffled 7 is the same again, right? 'Cause 7 is all the way through. So that's 1, 0, 0, 1, 0, 1, 0. And then this one shuffled 2 becomes 0, 1, 0, 1. 1, 1, 1. And that becomes, so we all start with 0, 1, 1. We start right here in the table. Lowercase letters. The first one is a B still, I guess, sure. And we go to 1, 0, 0, 1. An I. And then we go to 1, 1, 1 at the start, and 0, 1, 0, 0. There's a T. Bit. That seems like a good start. And we go down 3. Because we have 1, 1 at the end there, yeah. W. That's an I again, yes. 0, 0, 1, 1, we go up 4 from the W. Yes, becomes an S. And then we go to the zeros again, and then 0, 1, 0, 1 is, where is it? An E, bitwise. That has to be right. Yeah, okay, that's good. That's very good. I think we're gonna end it here because I have no idea what to do with this. We'll think about it off camera, but I don't really have a, I don't even have a starting guess what to do with that. I don't know what image is supposed to tell us. Maybe IMG doesn't even stand for image, who knows? Basic encryption standard to encrypt arrange text and key into 4x4 blocks. So yeah, T0, T1, T2, T3. That's the text, and then key K0 all the way over there is the key. Round 1 key YS, round 2 key BX. Swap columns 1, 2, and 3, 4 of each block. I'm confused by this. Substitute text block using key block. Shift rows of text blocks. Plus 0, plus 1, plus 2, plus 3. Complete 2 rounds. But like we have like in the text 4x4, we have 0, 1, 2, 3, 4, 5, 6, 7, and then that again. But we have how many digits here? 4, 4, and another 4, 4, right? 16. But it's like 8 bits each, right? So we go 1, 0, 0, 1, 0, 1, 1, 1, and then 1, 0, 1, 1, 0, 1, 0, 1, and then the key YS. We just have to look up the binary for that. I put it in the K sequence. And then, I mean, swapping the columns, sure, we can do that, of each block. So we ripped it, like, yeah, that makes sense to me. Substitute text block using key block. Like, how do you substitute the blocks, though? Like, each row? Each, like, cell individually, I guess, right? And then shift rows of text block. Plus 0, plus 1, plus 2, plus 3. I don't know why... Oh, the first... No. Okay, the first column gets shifted 0. and the second column gets shifted 1, and then the third 2, and the fourth gets shifted +3. Is that right? That would make sense to me, because they're 4, yeah, maybe. And then do that twice, you know, the second key. But that looks like a mess. It's gonna be tough to do. And I mean, or we're gonna get this 2 letters, so I don't know. But that one I think we can do. This one is just, we just have to be very focused, like very careful not to make any mistakes here. But I feel like all the instructions are like right here. Whereas for this one, this makes no sense, because none of these are letters. Like they are too high or too low, those numbers. Like down here we have 1 and 1 at the end. And I mean, you could read it like in columns or something. Whatever, we'll do that next time. We'll do it next time. We did 3 or 5, that's a good haul. Let's quit while we're ahead, and I'll see you next time. Bye-bye.